Let's talk about vertical asymptote and horizontal asymptote because they are pretty important when you do curve sketching. So let's say we have a function f of x equals to 2x squared plus 1 divided by x squared plus x minus 6. I also factor the denominator for you. So the reason I do so is because if you factor the denominator, you can pretty much tell what the vertical asymptote is. So vertical asymptote is a value that makes a rational function has a 0 in its denominator. So for example, if you have 1 over x, the reciprocal function, then x is equals to 0 is a vertical asymptote because when x is equals to 0, the function is undefined. So in this function, we have x minus 2 and x plus 3 in the denominator. So we have to say that x plus 2 minus 2 and x plus 3 cannot be equal to 0. So as a result, x cannot be equals to 2 and x cannot be equals to 3. So that means when x equals to 2 and negative 3, these are vertical asymptote. So on the graph, so for vertical asymptote, we will be using a vertical dash line. So when x is equals to negative 3, so right over here, so we will just sketch a vertical dash line. And then when x is equals to 2, so here is another vertical asymptote. So I will just call them a VA, vertical asymptote. One at x equals to negative 3, and then one at x equals to 2. And then the other one is horizontal asymptote. So for horizontal asymptote, that affects the left end and the right end behavior only. So look at this graph for the vertical asymptote. On the left hand side, you have to look all the way to the left end. So right over here, so you have to look all the way to the left end, and you have to look all the way to the right end. So how do we find the horizontal asymptote? Simple. So all you have to do is you set a limit and let x goes to infinity. So we have limit as x approaches to infinity. So this tests the right end as x approaches to positive infinity, and then 2x squared plus 1 divided by x squared plus x minus 6. And then the next step is you have to divide each term by x raised to the highest degree in the denominator. So let's write that out. So we have to divide each term by x squared because second power is the highest degree in the denominator. And then the next step, we have limit as x approaches to infinity. So we have 2x squared divided by x squared plus 1 divided by x squared, and then divided by x squared divided by x squared plus x divided by x squared minus 6 divided by x squared. And then you clean up the exponents. You have x goes to infinity, so the top is 2 plus 1 divided by x squared, and then the denominator is 1 plus 1 over x, and then minus 6 divided by x squared. So once x approaches to infinity, you have a 2 divided by 1 that is equals to 2. So y equals to 2. This is a horizontal asymptote. I will just call it a VA. So as x approaches to negative infinity, you get the same thing. Y approaches to 2. So horizontal asymptote is y equals to 2. And then the way we sketch that is we draw a horizontal dash line. So like this, when y is equals to 2. And then one question that you might ask me is, hey, as x approaches to negative infinity, y approaches to 2, I get that on the left hand side. But how about this? As x approaches to positive infinity, y approaches to 2. It looks like the graph, so this curve right here, just crossed the horizontal asymptote. What happened? Do you see that on the graph? It looks like on the right hand side, the graph just crossed the horizontal asymptote. Yes, you're right. So when x is equals to, I don't remember what that number is because I didn't write it down. When x is equals to a certain number, so when x is equals to a certain number, y is equals to 2. Somewhere right over here, all right? So if you look carefully, I am talking about the right hand behavior. So on the right hand side, here is what you're supposed to see if you zoom in the graph. Okay, so let me say this one more time. Yes, on the right hand side, this curve crosses the horizontal asymptote at some x value. I don't remember what that x value is. Maybe it's x equals to 6.5. I don't really remember when x is equals to 6.5, y is equals to 2, because I don't have the record in front of me and anymore. So this one, since I'm not sure, you can try when x is equals to a certain number, y is equals to 2. So this one I'm not sure, so let's just don't put this on my notes. So if you zoom in, here is what you will see. Okay, so on the right hand side, so you will see a curve. First you will see a horizontal asymptote. So this is a horizontal asymptote. Y is equals to 2. And then the curve, let me just use purple. So here is what you will see. Yes, the curve is decreasing, and then it will just cross the horizontal asymptote. And then this is what happened. So it will cross the horizontal asymptote and then come back up like that. So as you look all the way to the right end, so as x approaches to positive infinity, y approaches to 2. It will just cross 2, cross y equals to 2, so drop down a little bit and then come back up. And then on the other side, on the left hand side, the graph just approaches to y over 2 like this. It will not cross y over 2 first and then come back up. Okay, so that is vertical asymptote. And horizontal asymptote, I want to review one more thing. So that is called the removable discontinuity. So I will be using a similar function. So removable discontinuity means the vertical asymptote can be removed. So look at this function, x over 2 divided by x minus 2 divided by x minus 2 times x plus 3. So as you can see, the x minus 2 can be cancelled. So when you sketch the graph, you are really graphing 1 over x plus 3. So for 1 over x plus 3, what can we say? We know that x cannot be equals to negative 3, right? So that means when x is equals to negative 3, there is a vertical asymptote. So when x equals to negative 3, there is a vertical asymptote. So x equals to negative 3 is a vertical asymptote. So, and then one other thing that we can say is as x approaches to negative 3 from the right, y goes to positive infinity, and as x approaches to negative 3 from the left, y goes to negative infinity. So as a result, if you set the limit as x approaches to negative 3, the limit does not exist. Okay, and then how about the vertical asymptote? So for the vertical asymptote, you have to do limit as x approaches to infinity, 1 divided by x plus 3. So since the biggest degree in the denominator is 1, you have to divide each term by x raised to the first power. And then you will get limit as x approaches to infinity. So the top you have a 1 over x, and then the bottom you have a 1 plus 3 over x. So once x approaches to infinity, then you will get a 0 divided by 1 plus 0, which is equals to 0. So y equals to 0 is a horizontal asymptote. HA, so y equals to 0. But and as x approaches to negative infinity, you get the same thing, y approaches to 0. So let me use a different color. So let me use red. So x equals to 0, then you have this. So this is y equals to 0, so that is your horizontal asymptote. Hey, it looks like if you look at the beginning of the function, you have a x minus 2, right? So it looks like we have x, let's use a different color. It looks like we have x equals to 2 as a vertical asymptote, but you just cancel my vertical asymptote, then I don't see it anymore. Do you see this on the graph? When x is equals to 2, the function is undefined, so that's why there is an open circle. Maybe I should not draw on that. So there is an open circle. Do you see that? So the graph looks like this. So the piece on the right, so it looks like this. And then when x is equals to 2, there is an open circle. So for the removable discontinuity, you will just use an open circle. So that stands for a removable discontinuity. You still cannot let x equals to 2, because when x is equals to 2, the function is undefined. Okay, so that's how you graph and how you see the removable discontinuity on a graph. Okay, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share this video in any social media for me. If you are new to the channel, please take 2 seconds to click the subscribe button down below. Thank you for your help and support. I will see you all in the next one. Signing out.